Everybody, let's talk about solving a system of equations by substitution. So probably by this point you have seen solving a system by graphing. This is just another method you can use solving a system by substitution. Now, whenever I do graphing, I typically look for like a y equals and a y equals. That typically tells me I should be graphing. For these types of problems, whenever I see just one of my variables, either x or y, by itself, like a y equals situation, or even down here, an x equals situation, that immediately tells me I should probably look to substitute. So if you could just get one of your variables alone, it doesn't have to be alone in both or all the equations in the system. If you just have it for at least one of the equations, that tells you you should be substituting. So for our first problem, we have y equals 5x minus 7, and we have negative 3x minus 2y equals negative 12. So what I'm going to do is solve this one by substitution. So when I see y equals 5x minus 7, I see the y is all by itself. So what this means is anytime I see y, I can substitute or plug in that 5x minus 7. So anytime I see y, let's replace it with 5x minus 7. So in my second equation, where I have negative 3x minus 2y equals negative 12, I'm going to replace this y with instead plug in parentheses and say 5x minus 7. So this is going to be substituted or plugged in right there for y. So it's almost like I'm taking both my equations and plugging them into each other to get one equation. So if I rewrite my second equation, I have negative 3x minus 2. Instead of the y, I'm going to put parentheses 5x minus 7 parentheses. So I replace the y with 5x minus 7, and this is equal to negative 12. So just like that, I've gone from equations that have both x and y in them to a single equation with only x's. So I can easily solve this for x. So if I'm going to solve this for x, and I'm going to try and clean it up a little bit, I see the parentheses here first, which means I'm going to distribute. So I'm going to take this negative 2 and distribute it all the way through my parentheses. So I would have negative 3x still from this first piece. Negative 2 times 5x is negative 10x. Negative 2 times negative 7 is 14. And this is equal to negative 12. After I get rid of the parentheses, I see a few like terms here. This negative 3x, negative 10x, we both have x's here, so those can be combined. Negative 3x and negative 10x is negative 13x plus 14 equals negative 12. So we've gotten it all cleaned up a little bit there, distributing, combining like terms. Real easy solving here, just minus 14, minus 14. That should leave you with 13x equals negative 26. And running out of room here, but you're going to divide by 13, divide by 13, and we get x equals, there should be a negative there, negative 13. X equals positive 2. Forgot my negatives there. So solving here, pretty simple, get x equals 2. Now, remember, when we're solving systems, we're looking for the coordinates here, so the x and y coordinate. Right now, I just have x is 2, so I got to figure out y. What you're going to do is take whatever variable you just found, either x or y, you're going to plug it back into either of your two original equations. Doesn't matter which one. You're going to plug your x into it and use that to solve for y. So I'm just going to use the top equation I have listed here, which is y equals 5x minus 7. I'm going to take that positive 2 and just plug it right in. So we have y equals 5 times 2 minus 7. Clean that up. Y equals 10 minus 7, which is y equals 3. So I have my ordered pair 2, 3. I could take this and check it if I wanted to. Take 2 and 3, plug it into the top equation, make sure it works. Take 2, 3, plug it into the bottom equation, make sure it works as well. It's a very easy method. Probably the toughest part is the actual substitution, knowing where to substitute. As far as that, you just got to be careful. Obviously I made a little mistake, but I caught it on my negatives there. But pretty simple process once you get started. All right, so my second example here, I have negative 7x minus 2y equals negative 13, where x equals 11 plus 2y. So again, I have one of my variables all by itself. That is telling me, hey, substitution's a good option. The way this problem is different is we have x is equal, not y is equal. So when you see x is equal, I know I could replace all x's with 11 plus 2y. So I'm going to replace all x's with 11 plus 2y. You want to be very careful. Some people just get caught with, oh, I automatically just substitute in for y. No, you got to pay attention. So we're going to substitute for x and plug in 11 plus 2y. So in the top, that x is going to be replaced or substituted with parentheses and 11 plus 2y. So rewriting that top line, I'm going to have negative 7. There's my parentheses, 11 plus 2y, parentheses, minus 2y equals negative 13. So very, very similar to my first problem. I substitute in. I went from having equations with x and y to just one equation only with one variable left. We just have to distribute, combine like terms, and solve to get our variable y. So negative 7 distributed on through. So negative 7 times 11, that is negative 77. Negative 7 times 2y, that's minus 14y. And I still have a minus 2y hanging out. Still have a negative 13 as well. After distributing through parentheses, I see these like terms here. I see a negative 14y and a negative 2y. Those can be combined, and we get negative 16y. Still have a negative 77 hanging out, and this is still equal to negative 13. So, did my distributing, combine like terms. Pretty simple equation from here on out. Add 77, add 77. That leaves us with negative 16y equals 64. Divide by that negative 16, divide by that negative 16. We're left with y equals negative 4. So as always, we're trying to find the coordinates for where these two lines crisscross. I know the y part of the coordinate is negative 4. Just got to figure out the x part, because I solved for y. So again, what I'm going to do is I'm going to take this new piece of information I have, plug it in into either of the two original equations, solve for my missing variable, x. I'm going to use this equation we use for substitution. It really does not matter which equation you pick. You'll still get the right answer as long as you do the math correctly. So it really doesn't matter. So I take this y equals negative 4 and I plug it in. I get x equals 11 plus 2 times negative 4, which is x equals 11 minus 8, which means I get x equals 3. So I have my coordinate 3, negative 4. That's where we're crisscrossing. If I want to, I could take this, plug it into the top equation to check, plug it into the bottom and check. I could do that if I wanted to, make sure I'm right. And that was solving a system of equations by substitution.